Okay, the session is now being recorded, and I have to. Okay, this is lecture 27, power electronics, inverter circuit, and waveform. So far, we have covered the DC-DC converters, and we have seen a number of things we need to improve the material in order to in order to get rid of the losses, and in order to make the converter क्या कहते हैं इसको, to make the converter number one was the losses, and number two was the the frequency response. Yes, so we have seen and we address two main factors. We target two main factors, and these two factors are now being targeted internationally in the institutions, in the universities, in the industries, in the research centers, everywhere. It is targeted that how we can make the converter, the DC-DC converters and the inverters, how we can make them highly efficient, and also how we can, and in order to make them highly efficient, we must have to increase the frequency we have seen. And so the two targets are now being traced. Now are the challenge. Number one was the losses, that means the efficiency, and number two is the getting the higher frequency operation. So we have discussed, and now we stop the DC-DC converter. So we have to, because we have to cover a lot of things more, but the basic knowledge we delivered you what is happening in the DC-DC converters and what the challenges, the current challenges in the international research is to meet these two targets. And we have now we stop this topic. Now we have to start the inverters. Of course, the inverters are also based on the high switching transistors. I mean, inverter is also operated at high frequencies. The same thing will apply, the same the losses and the same the frequency, higher frequency limitations will also apply in these inverter switching transistors or switching devices. So keeping in mind all these things, we have to now start the inverters. But for the inverters, because you already have done some mathematics in the previous semester for them in the electrical machines, in some electronic devices, something like electronic circuits and analysis you have done. So we only will focus only these two things: power electronics inverter, this circuit, how we can formulate, or how we can understand, how we can draw the equivalent circuit, and then the waveforms. So this course I will limit for the circuit understanding, and if you now understand the circuit, then of course you will be comfortable to draw the waveforms. So these two things we will try to consider, try to understand very clearly in this topic. If you have any question, you can start. Okay, I assume, and I not it's the assumption, but it is true that you are all know about the inverters. So inverters are static circuits. Static means this is not the generator, this is not the something electrical machines, but this is the static electronic switches like transistors, diodes. So inverters are static circuits that converts DC power to the AC power. The inverters are used in many industrial applications, including speed control of the induction motor. This is the main part of the inverters. In this main part, majority of the inverters are being utilized. So the challenge in the inverter design is nowadays is mainly for the operation, for the control of the induction motors. You know, previously the induction motors were supposed to be run only in the AC by the AC source of supply, but nowadays the inverters can also be run by the, sorry, the induction motors can also be run by the DC controllers or by the AC controllers, but by varying the speed. Okay, sorry, I have to tell you once again. Previously, the induction motors were supposed to run in the AC supplies and at the fixed AC supply frequency. Okay, if we apply a fixed frequency supply to the induction motor, it will have also the fixed fixed speed, right? So if we want to make induction motor as a variable speed machine, then we have to use the inverters, and we have to use the inverters and the converters. Okay, so the main power inverters are covering the speed control of the induction motors, and then induction heatings, aircraft power supplies, uninterrupted power supplies, and high voltage DC transmission. This is the latest work in the electrical sides, in the power electronics, high voltage DC transmission, HVDC. A half-bridge basic inverter circuit. I'm a little bit going fast, so that I assume you all know about these basic things, but because we have to start from the basic, so this is the basic structure of the inverters. Okay, and we have to connect here in between these two terminals, these four terminals. We have to connect our load. So what is this? This is the inverter. What is happening in this? Nothing is special. We are just using DC, one single DC supply. Means, for example, if we have 100-volt DC supply, so this is your 100-volt DC supply, and you just make this arrangement, and then you will get the inverter circuit. So this is the basic version of the inverter circuit. So now you have this inverter circuit. Now you have to connect the load. For example, आपको पास कोई DC supply है, आपको supply तो available है, आपको क्या करना है, उस supply के output पे आपको अपना load connect करना होता है. The same thing we have to do here. This is the inverter basic circuit, and we have to now connect the load. How we can connect the load? This is the main technique. So for example, if we have this load, and of course this time this load is a resistive load. So if we have this load and we connect one terminal of the load with this supply and this terminal of the load with the lower terminal, so it means we are using switches. Number one, S1 switch, and the load terminal T1 here. The load terminal T1 is positive. Why it is positive? Because this is connected to the positive terminal of the source. And we need switch 1. We need also second switch, because we have to connect the load with this terminal, with the inverter. So the second switch is S2, then that is connected with the negative supply. So in this case here, the supply will be negative. So this terminal T2 is negative, and in this way, the output at the load is plus. If we start to see from S1 side, if we place multimeter, DC meter, red lead here and the black lead here, then we will read the plus supply voltage, and this is exactly equals to the supply voltage. Okay, so this is the one part of the inverter, and now the second part. In the second time, we change the switch S1. We change the switch S1, instead of to the upper side, we moved switch to the lower side, and we also change the switch S2 to the upper side. So now in this condition, we can see here this terminal T1 is negative. Previously it was positive, and now this terminal, this T2, is now positive. positive, but previously it was negative. So what happens now if you connect multimeter red lead here and black lead here, then you can find the voltage will be negative. And whatever be this voltage, for example, if this was the 100 volt, so then you will get here minus 100 volt. So what we are getting at the load, we are getting here in this arrangement, in this switching status. These are the switch states or switching status. So switch status, in this switch condition, the voltage is positive across the load, and in this switch condition, the voltage is negative. So what we are doing from this single source of DC supply, we are getting here plus voltage and we are getting here minus voltage. So the output is changing from plus to minus, minus to plus, plus to minus, minus to plus. So it means the output is an AC alternating voltage and the alternating current. So from the single source of supply, we are getting plus supply at the load and the minus supply at the load at the same at different times. So this load, this circuit is known as the inverter. It converts DC supply to the AC supply. Okay, hope you understand. Half bridge basic inverter circuit. This is half bridge because it uses two switches S1 and S2. We are just using two switches S1 and S2. So if we use four switches, then it will become full bridge. S1 and S2 as per table 1. So we know this load, especially this load is connected to the inverter via these two switches S1 and S2. And these two switches can be either this side, can be either on this side, or can be either on the neutral side. If the switch is in the center, it means it is not connected to any of the terminals, this one or this one. So this is just switch is in air, or it is in the neutral position. So this is half bridge because it uses two switches S1 and S2. S1 and S2 as per table 1 repeats the combination of two switches to provide the square wave voltage at the load. Now we have to draw. Now we understand the circuit operation. हमने सर्किट ऑपरेशन हमने अच्छी तरह पढ़ लिया, समझ में आ गई. अब हमें क्या करना है, इसके वोल्टेज एंड द करंट वेवफॉर्म वी हैव टू ड्रॉ. In this, first we have to make a table that how the switches S1 and S2 are controlled. These are all the microcontroller based switches. So switch, we have state 1 in the single state. S1 is at positive. Where is S1? S1 is at positive. And S2 is at negative. S2 is at negative. Okay. What will be the output? Output as compared to T1 and T2, output is plus. So output is plus Vs. Now the second state. This is the second state. Here, the switch S1 is connected to the negative. S1 is connected to the negative. S2 is connected to the positive. And of course, in this case, if we take the reference T1 here, again the same reference T1, so we will find the negative voltage. So supply is negative. Now we have to. So all the types of the inverters are inverter switches. The transistors, IGBTs, are controlled by such types of table. Now it's time to draw the waveform. It is the waveform. So when the switch S1 is on, so output voltage is plus. This is plus. And this status is for state 2. This is for state 1. This is for state 2. State 2 में voltage minus है, so voltage is minus. And then plus, then minus. So what we are getting at the output the AC voltage. But this AC voltage is basically having the shape square wave. Remember. So the today's topic is the inverter, how we can convert the DC voltage or any other voltage to a pure AC voltage. जो कुछ भी आपके इनपुट दिया हुआ, आपके इनपुट लो दिया हुआ है, हाई दिया हुआ है, DC दिया हुआ है, AC दिया हुआ है, whatever. We want to have output with an alternating current or the voltage, because the load needs to be connected with the AC voltage and the AC current. So the load needs to be connected. So if this, so it means this inverter circuit is providing this high, low, high, low. It's switching from plus to minus, minus to plus, plus to. So this is an AC output. Now, if you are with me till now, then we are getting the AC voltage from the single DC voltage. This is the task of the inverter. Now about the features or about the properties of the output voltage. The output voltage is not DC. Okay, it's not DC, it's a AC. When we talk about the AC voltage, it means we must have to tell at least three parameters of the AC. Number one, how much is the amplitude, means इसकी जो AC की जो plus peak है और minus peak है वो कितनी है. So when we talk about the AC supply, we must have to mention three parameters. Number one, it's magnitude, peak से peak कितनी value है. Number two is frequency, and how we can determine the frequency. This is your time period. यहाँ से लेके यहाँ तक आपके पास एक टाइम है. इस टाइम t है, कैपिटल T. इसको अगर आप 1/t कर देंगे तो you will end up with the frequency. So number one is the magnitude, number two is the frequency, and number three is the shape. What is the shape? This shape is a square wave, is a pure square wave. ठीक है. लेकिन what should be the shape of an AC of a good and proper AC voltage? We know from the wall outlet we get the AC voltage, and what are its three things, three parameters. Number one is the magnitude. Magnitude, we say that the RMS magnitude is 220 volt or 230 volt. Okay. Number two, what is its frequency? The wall outlet frequency is 50 hertz. Number three, what is its shape? The shape is sinusoidal because we are getting from the generators, the pure high speed rotating generators, and these provides pure sinusoidal voltage because shape is inductive output. So when we talk about the AC voltage, we must have to define its three parameters. Number one is the magnitude, number two is the frequency, and number three is the shape. So what about this? We are also getting this AC voltage. What about this AC voltage? What is its three parameters? Number one is the magnitude. What is the magnitude? Magnitude is the supply voltage. If the peak to peak is plus Vs to minus Vs. Okay. How we can control the supply voltage? Can this inverter increase or decrease the supply voltage? We can increase and decrease the supply voltage only by increasing or decreasing this source voltage. अगर आपके पास 100 volt source है, so you will get 100 plus 100 minus. अगर आपके पास 200 source voltage है, so you will get plus 200 minus 200 voltage. So we can control here the amplitude, but the only way we have is to increase or decrease the source voltage. Number one. Number two, about the magnitude. Number two, about the frequency. How we can increase or decrease its frequency. I mean, the frequency is 1 over t. So this is time को अगर मैं बढ़ा दूंगा, if we increase this time, for example, अगर ये 1 सेकंड के लिए ऑन रहता है, कौन ऑन रहता है? I mean this state 1. State 1 is okay, 1 second is too much. State 1 is, for example, 100 millisecond के लिए ऑन रहता है, तो it means इस पोजीशन पे स्विच S1 और स्विच S2 इस पोजीशन पे 100 मिलीसेकंड तक स्टे करेंगे. So we will get this voltage up to for the duration of 100 millisecond. Now after 100 millisecond, if the switch is changed to this position, then this switch will remain 100 millisecond. Okay, so this switch will, these status will remain as it is for the next 100 millisecond. So you can determine its frequency, 100 millisecond plus 100 millisecond, 200 millisecond, and then you can 1 over, you can make 1 over f, so you can get the frequency. Okay, what happens if we want to increase the frequency? Frequency increase करने के लिए आपको क्या करना पड़ेगा? Time period you have to reduce. Time period को आपको reduce करना पड़ेगा, ठीक है ना? So how we can reduce smaller this one? Instead of making this arrangement, keeping this arrangement up to 100 millisecond, we can make this arrangement to 10 millisecond. अगर आपने so 10 millisecond के लिए ये status रखा है, so this will become, this will shrink, and it will only stay for 10 millisecond, and then this down will be 10 millisecond. The frequency, you can look, the frequency will be high. So the conclusion is that yes, we get the output voltage and the output from the DC voltage to output voltage, and the output voltage is AC voltage. So this circuit is inverter circuit, and we can control the magnitude of the output voltage. We can control the magnitude of the output voltage by increasing or decreasing the source voltage. Number two, we can increase and decrease the frequency by making by changing the time duration for which this arrangement keeps on. So the time duration we need. So if we want to make the frequency very high, so this switch will from this status to this status, the switch will operate at a very high speed. So if it operates, if it changes its position quickly, fastly, frequently, so the frequency will be increased, right? If you have any question till now, please ask. It's time for the question answer session. Okay, so I think no questions answer, and it should be as it is, because you are in semester 8. So these are the just basic. But why I have drawn, in order to make it very clear from the very from the very root level, I normally start to teach you. So now this power inverter, chapter 10, Ashfaq Ahmed. So I think the same, we have this circuit, but what we want to tell you, table 2. Okay, so I said before, this switching operation can be controlled by the microcontroller by having such type of the table. So this table 1 provides you a square wave. Okay. Oh, I forgot to tell you about the last parameter. The first was the magnitude, the second was the frequency, and the third was its shape, its form. So this is not sinusoidal, but instead this is pure square wave. So, but while we talk for the inverters, normally the shape should be similar, equal, or close to the sinusoidal wave. So the ideal is for any kind of inverter, ideal ये है कि जो आउटपुट शेप है वो स्क्वायर वेव ना बने, बल्कि किस तरह की बने? साइनोसॉइडल वेव, स्मूथ राइज हो, इस तरह से खूबसूरत तरीके से ये चले, और उसके बाद इसी तरह से ये साइनोसॉइडल ये स्विच ऑपरेट हो. But unfortunately, this is not sinusoidal. This is just a square wave. So how this square wave is built by the operation of this table 1. Now we change the table 1 operation, and we see how this shape can be changed. The power inverter chapter 10 Ashfaq Ahmed table 2 shows 4 states. Now we have table 2, and in table 2 we have 4 states: state 1, 2, 3, 4. And for this state the S1 is this. Let's we draw the output waveform. So जब state 1 में है, this is for state 1 I think. State 1 में output कितनी है? Plus S1. नहीं, state 1 में S1 कहाँ पे और S2 कहाँ पे? S1 is at positive, S2 is at negative. So the output will be plus Vs. So the output is plus Vs. Let's suppose is state 1 is for this time duration. अब इसके बाद यहाँ से state 2 में move होते हैं. So state 2 में वोल्टेज S1 किस पॉइंट पे है? S माइनस पॉइंट पे. Where is S1? यानी कि S2 तो माइनस पे था ना, S2 माइनस पे था, S2 स्टिल माइनस पे है और S1 चेंज हो गया है माइनस पे. So the state 2 says that both the S1 is here and S2 is also here, which was already here. So the changing from this status to this status is in one more step. पहले क्या हुआ था? यहाँ से डायरेक्ट ये चेंज हो गया. अब ये थोड़ा सा स्टेप इंक्रीज हुआ है इन द सेंस कि पहले ये S2 माइनस है. अब आपने क्या किया? S2 को माइनस में ही रखा, एक स्विच को एज इट इज रखा, S1 को प्लस से मूव करके माइनस की तरफ ले आए. So now, and we stay for this state for time duration, for finite time, for fixed time duration. So अब ये भी माइनस पे है, ये भी माइनस पे. What will be the output voltage? Both the terminals at minus, so there is no differential voltage. So there will be no current, and if there will be no current, then there will be no voltage. So the output voltage is 0. So for the state 2, the output waveform will look like this. ये state 1 की waveform है. State 2 में output voltage is 0 है. You can see its output voltage is 0. Now state 2. Now move to the state 3. हमने suppose किया कि ये state 1, state 2 का टाइम खत्म हो गया है. इस ड्यूरेशन के लिए ये state 2 में था. अब it moves to state 3. So what happens in state 3? State 3 में भी इन्होंने क्या किया है कि इसे S1 को एज इट इज रखा है, ये पहले माइनस था, और अब S2 को इन्होंने सिर्फ चेंज किया है. So in steps. So if we do these things, S1 is in negative, S1 is negative. इसका मतलब है इसकी जो सर्किट ओरिएंटेशन है स्विचेस की, वो ये है. S1 is negative, S2 is positive. So what will happen? The output voltage will be minus. So let's see, the output voltage is minus. How we can draw the minus voltage here? Output voltage यहाँ पर minus है, minus Vs. ठीक है. And now move to the fourth step. Fourth step में क्या है? Both these switches are at positive terminal. Step में ये तो पहले से positive था, इसे भी इन्होंने positive में कर दिया है. So both the switches at the same voltage plus terminal. There is no flow of the current. There is no voltage differential voltage. So the no current means there will be no voltage. So the output voltage will be 0. तो आप ये देखें state 4 में भी, state 4 में output voltage 0, and things will continue. State 1, state 2, state 3, and state 4 is just 1, 2, 3, 4, 1, 2, 3, 4. The output waveform will this one. Okay. Now there are some questions, some basic question. What is the difference between the last waveform and this waveform? I remember the last, or you also remember the last waveform was, oh my god, last waveform कहाँ गया? Last waveform was something like this one. So the last waveform was a square wave. Trying थोड़ी सी सही नहीं बनी because I don't have mouse. I'm just okay. So the last waveform in the previous slide, the waveform was this one, and this one was a square wave. But what is the difference between this waveform and this waveform? Last waveform was, this waveform was drawn by using table 1, and this waveform is drawn by using table 2. The difference is significant here. It's very, very clear that this has direct shift of, for example, if the current is plus 100 volt, if the current is plus 100 amperes, and this is the minus 100 amperes, it says that the current shifts from plus 100 to minus 100 abruptly in a straightforward, not linearly, is straight line. So, but so it changes plus 100 ampere to minus 100 ampere, and then minus 100 ampere to plus. So it's a square wave. It's a short. But this case, this also is a square wave, but the square wave is split into two parts. पहले क्या है, यहाँ प्लस 100 एम्पियर से, प्लस 100 एम्पियर से करंट कहाँ शिफ्ट हुआ है, to 0 ampere, and it stays for 0 ampere, and then from 0 ampere to minus 100. So it also changes from plus 100 ampere to minus 100 ampere, but it has this step. So this output waveform is known as a step wave output, or this special name is quasi square wave. So this is the quasi square wave, or it's also called step wave. It's also called step wave. So please remember, the previous one was this one. This is known as the square wave output, and this where we have put some pause, some delay. We inserted 0 amperes. We split it, the whole change in the current at once into two steps. So I will ask you which one is going to be good for the inverter. Okay, of course, this is not good for the DC-DC converter because it looks like something like CCM, DCM mode of operation. But we are not studying the DC-DC converter. Now we are studying the inverter, and in inverter we must have to change the voltage and the current from plus to minus, minus to plus, plus to minus, minus to plus. So I will ask you which one is good, this one or this one, and what is your answer? Please answer me, any one of you. Okay, no one is interested.
स्टेप वेव वाली अच्छी होगी,
स्टेप वेव वाली बेटर होगी, दैट्स राइट। कोई और बताएगा कि व्हाट इज द रीजन?
सर ये साइनोसाइडल की तरह हो जाएगी अगर हम इसको फिल्टर करेंगे ना, एवरेज अगर हम इसका लेंगे।
एब्सोल्युटली करेक्ट। कि देखें, अगर आप यहाँ पर we talk for the three types of the parameter. Number one is the magnitude, number two is the frequency, and number three is the shape. So here the shape is concerned. Magnitude तो जो इसकी है वो भी plus 100 plus 100, ये भी minus 100 है. The magnitude is same. इसी तरह से time period, frequency यहाँ से लेके यहाँ तक time period है, ये यहाँ से लेके यहाँ तक time period है. The frequency is not a matter. Frequency is also same, but the difference is, the difference thing is that we want to move from a square wave to the sinusoidal. So this is also square wave, but it has its steps. If we draw something, if we make some filter here, something like this one, so probably in this case यहाँ पे से direct changes है ना, so maybe we will end up with this kind of filters, but it has this sharp values. अगर आप यहाँ filter लगाएंगे तो ये edges कम हो जाएंगे, but still we will have, okay, so still it's if we apply filter, of course, it will be better than this than just the square wave, because its corners are not smooth. But if you do these things here, so you can see here, यहाँ पर ये आपके पास ये बनेगा, फिर ये इस कॉर्नर पे बनेगा, फिर इस कॉर्नर पे ये बनेगा, इस कॉर्नर पे भी आएगा, और इसके बाद फिर यहाँ से ये देखिए ये इस, सॉरी मैंने कुछ ज्यादा कर दिया। सो इट हैज मेनी कॉर्नर्स, तो इसकी वजह से यहाँ पर स्मूथनेस आ जाएंगी, ठीक है ना। So we think that, okay, so the conclusion is that this is better in the sense. There are two reasons. Number one is a reason, as you said, this one is somewhat, it should not be equal. Of course, we cannot say, and because it is not equal to sinusoidal, but it's close to sinusoidal than this one after applying the filter. So this is better in this sense. Acha, दूसरी चीज क्या है? Here the change in the current is abrupt, plus 100 to minus 100, and this is not a good design. Here plus 100 say 0, the state's 0, is 0 set. So the stress on the devices is maximum of 100 amperes, maximum of 100 amperes here. But here the stress on the devices is directly 200. This is not good. Any question? Okay, I need to continue. So we have seen, so remember these two types of a square wave. Number one is the square wave inverter. Number two is the step wave or quasi square wave output. Quasi square wave output is little bit, only little bit better than square wave, but basically both are the same. So this square wave output has limited applications because the square, it is a square. This cannot be used in the inductive load. We will see in this today's lecture at how the inductive load is behaved in the inverter. But this cannot be used in the inductive load. This can only be used for the resistive load. For example, tungsten lamp, or for example heaters. जो इस तरह के जो नॉन स्टोरिंग लोड्स हैं, फॉर एग्जांपल रेजिस्टिव लोड, जितने भी रेजिस्टिव लोड हैं उन लोड्स के लिए दिस इन्वर्टर विल वर्क फाइन, ओके, ऑल द रेजिस्टिव लोड, ठीक है, लेकिन ये इंडक्टिव लोड के लिए it's not fine. So the square wave output has limited application. It can only be used only the heaters or the resistive load. Power electronics inverters the same. So there are some more example of the inverters I took from the internet, and because of short of time I just copied it. So this is the same inverter, but the last time we use here switch S1 and S2. So this is controlled by the thyristors, the SCRs T1 and T2, instead of having the S1 and S2. So we are now using thyristors or the SCRs. So how it will work when SCR1 is on. So how it will when SCR1 is on, so the current will move from here to here, and this side will be positive. And if SCR1 is off and SCR2 is turned on, जब SCR1 off हो गया, ये तो off हो गया, अब SCR2 on है. So we can see here the supply is positive. So this terminal will be positive. The current will flow from here to in this way. Okay. So first half, the current will flow in this way when the T1 is on, and if T2 is on and T1 is off, the current will flow in this direction. So in both the case, we can say in this case current is in this direction, this will be plus. In this case, current is in this direction, so this will be plus. So we are getting anyway the alternating voltage. output alternating current. Usually, oftenly, maybe always, any semiconductor switch is associated with the freewheeling diode, like this one. जितने भी ये switch है T1 and T2 transistors हो, IGBTs हो, MOSFET हो, whatever be this thing, you will see soon कि कुछ samples में diode already इन्होंने insert कर दिया कि this is essentially required. तो ये switch है and the diode is always connected in the reverse polarity. So you can see इसके cross, इस anode के cross एक diode लगा दी cathode. Also this diode is connected in reverse bias. So if this is plus, so this will turn on, this will not turn on, and we will see soon how it is good, how this is used in the inductive load. So all these switches always. So whenever we draw the inverter circuits, because in the inverter we are using the semiconductor device as a switch, so this will always be associated with this kind of diodes. In order to understand first the circuit, you can ignore initially these diode. आप इसको ignore कर लें और इसे understand कर लें और इसके current direction or equivalent circuit you can draw. After that, you can place this diode. I should not say freewheeling diode, but it looks like a freewheeling diode. So the output waveform is this one. When Ig1 is applied, where is Ig1? Ig1 is the gate of the thyristor 1. This is ये gate है. इस पे जब मैंने ये on का apply किया तो ये on हो गया, the current will flow. This direction, the output is plus. So आपने देखें इस waveform के लिए output value की plus हो गई है. और इस time duration में ये T2 off रहता है. Next, after this time, the T1 is off, means gate is off, but this is on, gate 2 is on. इस gate 2 को on कर दिया इन्होंने. जब gate 2 on हो गया, supply is now reverse. So the supply is reverse, and you can determine the frequency by measuring this time period. You are having now this peak to peak value. The magnitude of the output value is plus Vs upon 2 minus Vs upon 2. Okay, and the shape is clear, is visible, that the shape is a square wave. And simple single phase. Okay, yes, this is the, again, initially you can drop this one diode, and then you will see the circuit is neat and clean. So it has 4 switches, T1, T2, T3, and T4. So this is the single phase, but full bridge inverters, and correspondingly, because we have 4 transistors, 4 SCRs, so we have 4 diodes. Its waveform will be, because the load is resistive, so the waveform is like this one, as we have explained this one. This can also be this is this one, and this one is the same circuit. We are here using the thyristors, and here it is used the bipolar NPN transistor. So these are just using the NPN transistor. So both are, the circuit are same. But if you are asked in the examination using the BJT NPN transistor, then you should draw this circuit. If you are asked to draw the circuit using thyristors, then you need to draw. If you are asked to draw the circuit using IGBTs, then you have to draw the symbol of the IGBTs here. Operation of half bridge inverter with resistive load. So as we said before, क्या time पे हो रहा है? Okay, I think we will cover. I think I started late, so can I continue for few more minutes? If you have no further onward class, please. Can I continue? Okay, I should continue. So operation of half H bridge inverter with resistive load R. ये देखिए ये इन्वर्टर है आपके पास है, right? ये इन्वर्टर है. You purchase from the market or you design yourself. This is half bridge because this S1 and S2, and this time we are using the IGBTs. Normally we use IGBTs. Don't use transistor. You can also use MOSFET, but it's always better to use the IGBT symbol. So you can see the IGBT symbol has this diode, reverse diode, already connected in the symbol, and this is the inverter circuit. Input is there. Output we can tap from T1 and T2. If you have any circuit, if you have any, for example, if you have any load here, अगर आपके पास ये लोड है, if we have any load, sorry, so we can connect this load. इसको यहाँ पर कनेक्ट कर देंगे आप, और इस वाले टर्मिनल को आप यहाँ पे कनेक्ट कर दिया. So this will turn on if the transistors are operated. So here S1, so this is just load. So this is the inverter circuit. You can connect any types of load here. If we connect, the first example is to connect the load here using the resistive load only. So we have already discussed about the resistive load. So this, sorry, so this is the same. अगर आप यहाँ पर so this is the same circuit. ये क्या हो गया? Yes, we are here. So आपने क्या किया, यहाँ पर resistive load लगा दिया inverter में, and how we have explained once more the operation of the half bridge inverter. So this time this is off, this is on. The current will flow like this one, plus 2. No current through the diode D1. Current will flow through S1, and the waveform here, this will be plus, this will be minus. And similarly for the next operation, this switch will turn off and this switch will turn on, and the direction of the current will be off or on. The direction of the current is in the opposite direction. Right? So this is the waveform. I already have explained you. What is important here, I want to focus because the load is resistive, and this is a resistive load. The voltage across resistor is this one, and the current to resistors is this one. So if we see these two things are these two, this one, this is the voltage waveform of the load, and this is the current waveform of the load. So we can see that the voltage and the current waveform are exactly in phase. अगर ये high है तो ये भी high है, ये low है तो ये भी low high. So and why the voltage across the resistor and the current through the resistor are in phase? Because there is no phase difference, because we are using resistor as a load, and load is not it has no storing element. So if we finish this one, and the next slide we will complete in the next class. Now it's time for the attendance, please. Muhammad Rizwan.
Present.
Ahmed.
Yes, sir. Present.
Muhammad Tahir.
Present.
Imran. Talia Amir.
Present, sir.
आमना इमरान या तालिया आमिर?
Sir, Talia.
Imran is absent.
सर आमना प्रेसिडेंट उनका माइक खराब है वो चैट पे लिख रही है
चैट पे अच्छा
Sir, excuse me.
हाँ सही सही प्रेजेंट नताशा राव
Present, sir.
मोहम्मद अली मोहम्मद अली मोहम्मद फहद इम्तियाज
प्रेजेंट सर
शाहिद राव
प्रेजेंट सर।
खालिद
Present, sir.
शफकत अब्दुल्ला आसिफ भट्टी
प्रेजेंट सर।
अब्दुल्ला सिद्दीकी
प्रेजेंट सर
आसिफ
Present, sir.
सयाब अफरा सयाब खान no longer has access to chat. क्यों भाई? Okay, I mark शहरियार खान
Present, sir.
शारिक रहमान
Present, sir.
आलिया अशरफ
Present, sir.
मोहम्मद एजाज अकरम
Present, sir.
अब्बासी समन अब्बासी
Present, sir.
रेहान समन अब्बासी आपका आपका एनरोलमेंट नंबर क्या है?
097.
रेहान अहमद
Present, sir.
आफिया शाहिद
Present, sir.
अजीम आजम तारड़
Present, sir.
ओके क्लास इज ओवर थैंक यू
Sir, अफरज से आप present हो.
Sir, Faraz Ahmed present.
Sir, अफरज से आप present.
फराज अहमद प्रेजेंट है हाँ सही है प्रेजेंट है अफरा से आपको भी मैं प्रेजेंट थे क्या आपने कुछ लिखा है?
Present हो sir.
अच्छा मैं एब्सेंटीज के नाम कॉल
Sir,
करता हूँ
अफरज से आप present.
मोहम्मद अली एब्सेंट है अक्सा शफकत एब्सेंट है बस ये दो एब्सेंट है अगर ये दो प्रेजेंट हो गए तो मुझे बताएं मोहम्मद अली और अक्सा शफकत दे आर एब्सेंट ओनली ओके इसको मैं सेव मैंने कर लिया इफ यू हैव एनी क्वेश्चन यू कैन आस्क रिलेटिंग टुडेज क्लास और एनी क्लास अदरवाइज आई हैव टू फिनिश किसी को क्वेश्चन
सर
करना
ये
तो करिए।
सीईटी से सवाल करना था सर ये
सीईपी जी पूछे
वर्ड
पूछे
सर ये वर्ड वर्ड पर बनाने या हम पेपर पर कर लें सर?
नहीं इसको हैंड रिटन बनाए प्लीज यार हैंड
ठीक
रिटन
है
बना
सर।
के स्कैन कर लें और
जी सर।
इसको थोड़ी सी अच्छी तरह अंडरस्टैंड करें और इसके प्रिंट आउट जरूर निकालिएगा ताकि फिर वाइवा बेस होगा ये तो उसके मुताबिक फिर
जी सर।
अच्छा सर
जी
सर LMS पे लेक्चर 25 और लेक्चर 22 की वो स्लाइड्स अपलोड नहीं हुई हुई मतलब जो PPT है ना तो वो अपलोड नहीं हुआ हुआ सर लेक्चर 22 और लेक्चर 25 जो आपने लास्ट क्लास में कराया था डायोड्स वाला।
अच्छा मैं नोट कर लेता हूँ लेक्चर 22 और 25
यस सर तो
मैंने PDF अपलोड किया हुआ है पीपीटी तो नहीं किया हुआ किसी का भी मैंने पीपीटी तो आपको ऑलरेडी वीडियो पे आ रही है ना
सर जो आप जैसे आपने ये स्लाइड्स से आप हमें पढ़ाते हैं ना तो जो दूसरे लेक्चर्स की आपने उसमें अपलोड की भी है ना LMS पे लेक्चर
हाँ जी
तो उसमें लेक्चर
चल मैं आई विल सी इट अच्छा दूसरी चीज मैंने कुछ वीडियोज है ना YouTube में अपलोड कर दिया है तो यू मे ऑल्सो ट्राई, आप लेक्चर नंबर लिखे, मेरा नाम लिखे, शायद यूट्यूब में आ जाएगा वो लेक्चर्स, लेकिन इट्स नॉट कंप्लीट, इट्स नॉट अप टू डेट। कुछ मैंने डाल दिया क्योंकि कुछ लोगों को प्रॉब्लम आ रही थी, मैंने डाल दिया, बाद में यूट्यूब से मैं निकाल दूंगा क्योंकि कुछ बहुत अच्छी स्टैंडर्ड की इंटरनेशनल क्वालिटी की नहीं है, तो मैं आई विल रिमूव इट। आप लोग को जो भी करना है एक्सेस करना है, ठीक है? ओके, अल्लाह हाफिज।
ओके, अल्लाह हाफिज़।